Hi. So my name is Andrew Ryan. I'm an app ops engineer at Facebook. I've been at Facebook for a year and a half, full-time, working in the data infrastructure group, which is the primary user of Hadoop. So, as you can see in some of the slides in this talk, the usage of Hadoop inside of Facebook is expanding to a lot more than just kind of your typical traditional MapReduce paradigms, and that's part of what I'm here to talk about. So the first thing I'll talk about is just a quick overview of what we do at Facebook to manage Hadoop. This is always, as a system administrator, it's always interesting to see what other people do at other big shops, and so I'll give a little bit of insight to how we do it. And talk about some of our existing operational best practices, things that have gotten us to the point where they are today, and then the challenges ahead. So you're hearing about some of the new directions in Hadoop, MapReduce. There's also new technologies like Hbase and other things that we'll talk about today that are really expanding both the challenge and the opportunity available for users and developers and administrators of Hadoop. And finally, we'll talk about some of what those emerging operational best practices are going to be based on what we see as the upcoming opportunities and usages of Hadoop and where we're going in 2011 and beyond. So it's a very next generation kind of night here. Okay, so like a lot of Facebook Hadoop operations is leanly staffed, fast-moving, and highly leveraged. So what does Hadoop operations look like? Well, we have a 24/7 site on-call team that does the entire site, the entire website, facebook.com, everything internal, external, and in between. And they handle like generalized farms and stuff, and so they do a very basic level of troubleshooting. The level 2 team, which I'm a member of, 2 people, we trade 1 week on call shifts, and hopefully we handle most of the rest of the stuff. And then level 3, we have, I believe, 4 different Hadoop dev rotations with one week each that are staffed by engineers. And so most of the operational issues, I would say, are either resolved at level 1 or level 2. Most of the development, I think a couple of them here in the room right now, I think their overnight weekend load is pretty low for the most part. They get a lot of, don't get me wrong, they get plenty of crap. At least, hopefully they don't get woken up in the middle of the night too much. And of course we have on calls for other adjunct teams like site ops, and we can fix a piece of hardware that's broken, or a net engine, can fix a switch or a router that's broken. And then every engineer is issued a cell phone, free iPhone, yay! But we're going to use it, and so buyer beware. Okay, so operational gaps in Hadoop. Anybody who has ever installed a Hadoop cluster other than on their dev box knows that all these things are true, and none of them are probably going to get better in any short time frame, because all the big users of Hadoop have their own solutions for doing these things. So I'm sorry, but you lose. So hardware selection, preparation, configuration, installation, packaging, upgrades, things like auto start, stop, your typical like init script type stuff, node level application and system monitoring, cluster level monitoring, log viewing, log tailing at either node level or cluster level, and then even things like fast, reliable, centrally logged cluster level shell. Don't count slaves at SH. It's meeting that criteria. Maybe there's vendors that, maybe Cloudera is working on these things, or some other people. I don't know. I would love it if they were, but in the meantime, you are working on it. Great. Unfortunately, even if they are working on it, when they go and sell to these large enterprises that actually need these, the large enterprises are going to say, well, that's great, but we already have our own way of doing these things, and so that's great, but we can't do this. This is why life is miserable for Hadoop administrators. So I've divided up our existing operational best practices into three categories. There's sysadmin, there's tooling, and then there's process. So sysadmin, this is a busy slide, so you can read some of it later. But all the stuff you do for a normal large distributed system, whatever that is. Hadoop in particular, this has been my experience, borne out pretty well by my 18 months, which is like 7 years of Facebook time, or the rest of the world time. But failing hardware is like the biggest enemy. And yes, there's things like speculative execution that sort of help sometimes, but most of our problems have been due to failing hardware, especially stuff that fails in weird ways. So Hadoop is pretty good at detecting a node that completely goes away. It just completely falls off the network and becomes unpingable. But when a node becomes somehow problematic, it will only send its map output to a reducer at 100 bytes per minute, and there's 5 gigs of it. The reducer just says, oh, this guy's slow. Yep, okay. So there's all these kinds of crazy things. So what we've had a lot of success with is just running every possible hardware diagnostic, checking our logs for memory errors, checking our logs for disk errors, querying whatever we can from the hardware, the network. Anytime we find these repeat offender pieces of hardware, which sometimes you get in your cluster, and we'll talk about that a little bit more, some of our data that we've got, get them out of there, even if you don't know what to do with them, even if your vendor won't take them back, I don't know, find some other retirement home. And then, some of the principles like fail fast, recover quickly, and get what you paid for. I'll just, 3 quick examples. I didn't know this until I started using it, but Red Hat Kickstart steals 3% of every disk. They're 1.5% in the partitioning, and another 1.5% in the ext3 file system because it uses 8K on inode. And the other 1.5 on partitioning is because it assumes that every disk may someday have a DOS file system, DOS bootable disk, and it reserves a bunch of cylinders at the beginning of the disk. So, use GNU parted, it will save 3% on your 2 terabyte disk, which adds up, by the way. Things like reboot out of memory. We had machines that would just go down and they wouldn't come back. So now when a machine OMs, because somebody wrote a dumb reducer, it just reboots and comes back. And then, things like ext3 FSCK, don't do it. If Hadoop can't read a file, it will tell you, actually throw an IO error. So, and then FSCK. But otherwise, don't. It's a waste of time. So here's an example. I'm sorry for the eye chart nature of this, but it wouldn't fit any other way. But so we call these America's Most Wanted. There are repeat offenders. They keep coming back and going to repair and causing problems in our cluster. Over here, starting from about this part over, there's our long tail of systems in repair, and how many times they've been in repair. There's actually one machine that's been in repair 11 times. And the thing is, at least at current, our process is pretty stable. So we fix it, we put it back in service, we assume it's perfect. And of course, that's not always the case. So in this graph, it shows 3% of the machines accounting for 43% of our repair events total for our cluster. And the thing is, 1% accounts for like 30% of the repair events. So, that's like, let's say 30 machines out of 3,000 are causing like 30 trouble that we have. So figure out what's going on with these guys and just get them out of your cluster. Okay, so some tooling stuff. Well, we've had a lot of success with it. Probably a lot of you don't have quite the number of Hadoop clusters in operation that Facebook or Yahoo has, but maybe you will someday. Maintain a central registry of the clusters and the nodes and what's in them, and what they do, and who uses them, and integrated with the ACID database, integrated with some kind of service management platform, whatever you have. Every big company has their own. Hopefully even the smaller companies have their own. This is a good idea. So we built a couple tools that interact with the central registry of clusters and the nodes. Hadoop CTL, Hadoop log, cluster CTL, excluderator to manage excludes files, and then some deployment and monitoring stuff as well. So these are just good things to have. Unfortunately, I mean, I would happily open source ours, but they'd be useless to you because they interact only with our service management platform and our asset database stuff and all the other stuff that we have. But if you're going into Hadoop in a big way, or if you're a vendor that's thinking of providing nice Hadoop-like services, build these, because we would like to have them. I would sure would like to have them a year ago. So here's an example of how you use that. I want to deploy. This is a couple thousand node cluster I want to deploy, and so this is what I say. I say deploy Hadoop release, and I say branch and rev, and it pulls it out of the correct repository, and then I run cluster CTL restart, and 4,000 nodes restart. Of course, it would be great if we didn't even have to restart. I'll get to that later, and that's part of what Arun was talking about as well. But today, that's how you do it. There's another example where we just do a redeploy, sort of a refresh, push all the software out to the nodes, like no matter if you have it or not. And then we can selectively restart, say, let's say the data node. We only need to do a data node restart and do that. So I wish Hadoop came with these tools out of the box, because it would have made my life easier, but we wrote them, so our life is easier now.
So why are you not giving the tools back?
Oh, like I said, I'd be happy to. It's just that all the stuff that they do that is integrated with our Facebook service management infrastructure would make them useless to anyone outside of Facebook. So, sorry. I mean, maybe I can post them anyway, but I feel kind of bad about posting useless stuff. Finally, process. This is a big this is a big subject, but I'm going to say, first document everything. Segregate different classes of users on different clusters, with appropriate service levels. Yahoo does this, we do this. If you have multiple clusters, you're probably going to want to do this as well. Graph user visible metrics like HDFS and job latency. So HDFS and job tracker and all these give you, in some cases, way too many metrics. They don't give you the right metrics to measure what the user experience for your users of your cluster is. And this is an area where we've spent a lot of time trying to get better at. Where we'd have our dashboards that say everything's great, and meanwhile users are sending mailing lists saying, the clusters are unusable, it's terrible, right? And so getting to that point of being able to have the same user experience as the users reflected in our monitoring has been a real learning experience and growth experience for us. And then, least destructive procedures for getting hardware back in service. So, okay, a machine fails or a disk fails. What do? Do you wipe the whole thing? Obviously you want to lose the least amount of data you can, so that's a good thing to do. And then, this is something that is kind of just more of a something that I've seen develop really well at Facebook, which is that developers and ops using the same tools for deploying and managing clusters. The success that we've had, you saw the command before. If you can run one command to deploy a new cluster, then it's easy, right? Anybody can do it. Now, you may say, oh, it's kind of dangerous, but it's also kind of nice because I can go on vacation and one of the other guys can deploy the cluster. There's no magic in it. Just run. They're running the same two commands that I am. And here's an example graph of some of the response time stuff that I was talking about. On the left is a DFS response time graph from one of our live DFS, and on the right is MapReduce. So this graph on the right is pretty interesting to me. It's actually showing a sleep job. So this is a job that runs with one mapper, 0 reducers, and sleeps for 1 millisecond. And you can see the minimum latency is 50 50 seconds all day long. Why? It's because we have a 3,000 node cluster, and job tracker, it's wretched for all the reasons that Loon talked about. But you can see even at some other times we went up to 200 seconds. So meaning like there's like 200 seconds before your most trivial job would even get scheduled in your cluster. Which had 3 slots, by the way. It was not a slot starvation issue. So sometimes we see that correlated with DFS problems. So for example, when DFS is slow, job tracker needs a lot of time to compute splits, and will therefore be really slow at scheduling jobs and everything backs up. But anyway, this is the bottom line. Kind of stuff, have the same user experience replicated in your monitoring that your users are getting on the cluster. Okay, so to recap, a little bit about this. Worst enemies, things that consume most of my time, or did in the past year, are the X files in America's Most Wanted. So we've talked a little bit about America's Most Wanted. These are the ones that keep coming back, the nodes that keep coming back and failing, and screwing up the jobs and running slowly and causing users to complain. The X files, well, these are the machines which fail in strange ways, which are undetected by your monitoring systems. And sometimes they're Hadoop bugs. They're Java deadlocks, or Java virtual machines not being shut down properly, or any number of things on that side. Or they're just weird system problems, like the machine's network interface suddenly decides to go to 10 megabits per second. Otherwise it's functioning fine, but incredibly slowly. So my advice for these as an administrator, to get your basics under control, and that will leave you some more time to go after these kind of X-file type machines. And basics include these America's Most Wanted, they just keep failing again and again. So get them out of there. Okay, so now what we came to talk about, new directions for Hadoop. These are 4 things that I see as big trends in operations for the next 12 to 24 months. And you may disagree, but this is what's important to us at Facebook. Hbase, zero downtime upgrades, metadata nodes, and HDFS is an appliance. Druba wrote a blog post about this, which is up on the Facebook engineering blog. So go on Facebook, search Facebook engineering, you'll see his blog post. These are some of the things that he was talking about. So we'll talk through each one of these in turn now. Hbase, just out of curiosity, anybody using Hbase here? Okay, a bunch of users. So cool. It's very new technology with emerging operational characteristics, which is the administrator's nice way of saying, it's not that stable. And now, on top of this, the applications using Hbase are also new. So they're trying to figure out how best to make use of all the capabilities of Hbase and application level and make the changes simultaneously to Hbase and HDFS and all these other things. So there's a lot of moving targets there. Our usage of Hbase is a large number of approximately 100 node clusters. So we're not trying to go any bigger than that with Hbase for now. And that does have some challenges on the number of clusters, but we feel like it's a more manageable number of Hbase right now. Now, slow and dead nodes, I talked about that being our biggest problem in MapReduce. In Hbase, it's 10 times worse because these are real-time user-facing systems. There is no speculative execution in Hbase. You have a slow region server, you have slow queries, you have slow user response. That's the bottom line. So this is going to be a real key component of our monitoring coming up next year. And the region failover question. Yeah, so the question is, how do we handle slow? I'll get back to that. The shorter answer is, it's an ongoing process, right? And also region failover is slow. So when a node dies, I want to say slow, it'd be like 30 seconds, right? But 30 seconds is like enough to make web requests time out, right? And you really have to avoid full downtime restarts. It's not really acceptable for Facebook to go say, oh yeah, sorry, we're Facebook, but we're taking a downtime, right? And that's not cool. That's not Facebook. So there's a messages tech talk at this URL, which also links from the Facebook engineering blog that I linked to before. It talks a lot more about this. So I'm not going to go into detail here, but big challenge for Hadoop administrators. Okay, so zero downtime upgrades. Now, this was mentioned in Arun's talk, right? We need to be able to upgrade clusters without taking gigantic downtimes. We can't today, at least without doing things like killing all of the jobs and tasks. And what it means is, so we need to figure out how to do rolling upgrades, and we need to figure out how to do every single daemon in Hadoop, not just job tracker, but we need to figure out HDFS rolling upgrades. We need to figure out Hbase rolling upgrades, and we need to be able to do things like be able to be strict and lenient at the same time about which versions of Hadoop are running in the cluster. So some versions are okay to talk to each other, some versions are not, and some versions have to be blacklisted, some versions, you guys know the drill. So this is a real big challenge. And this is not just an operational challenge. Obviously, there's a lot of code being written in Hadoop and other sort of software to support this, but these are the things we're working on. So we're close on HDFS with the Avatar node. It's getting there. We're job tracker. It's getting there. Is what I can say. Hbase. I think by the end of 2011, we will have zero downtime upgrades as a reality. Not necessarily the norm, but they will be possible. So actually, I hope by before the end of 2011. The question was, do we do rolling upgrade with Avatar or without? And at least on HDFS, it's only theoretically possible with Avatar node. It's only theoretically possible with Avatar node. At least for us. I mean, you could sort of do a data node upgrade today with the name node. It just takes a really long time. So we tend not to do it. Okay, mega data nodes. This is my own word because I don't have a better word for it. And Hadoop writing. Now, Arun talked about some of the specs for their machines. Not surprisingly, ours look similar. In 2009, our machines had 4 terabytes of disk. Oh, those innocent days of 401 TB disks, right? Because the machines I'm getting in Q3 have 12 3-terabyte disks. Okay, and the machines I'll get next year probably want 4 terabyte disks. So now all of a sudden we have 36, maybe 48 terabytes per node. And I can't really negotiate a lot on this because we need the storage, we need the density, and I can't fill up vast miles of data center space. We have to figure out how to make it work. But, okay, so you can say, all right, that sort of works. I can see a Hadoop node, still get 3x replication, still maybe make it work. Oh, but now we're doing this RAID, right? I don't know, how many of you saw Ram's talk in December, Hadoop RAID? A couple of you. So 3x replication doesn't cut it for archival storage. So we're going to read Solomon, we're going to XOR 2.2, 1.4 replication. But now that means when a node dies, it's got thousands and thousands of blocks that have to be replicated up. How? I don't know, right? I lose a rack. I mean, in the read Solomon world, it's if we were running the read Solomon right now, it's a 3-4 hour per node recovery time, and that's with 24 TB nodes. It's only going to get worse, right, before it gets better. And you also need to be really careful about block placement policy inside of HDFS, so that you don't put blocks, parity blocks, and data blocks in the same place. How fast is our network? Our standard node level is one gig interface, and then at the top of the racks it varies. So up to 10 gigs at the top of each rack. Well, the problem is it's read Solomon. So we're actually doing we're having to reconstruct blocks for parity. So, in other words, there's only one copy of the actual block. The rest of it, you need to recover that. If that node dies and that the actual copy of that block disappears, you have to reconstruct from all these parity blocks. And that's expensive. You can go look at Rom's talk from the last user group. It talks more about the Reed Solomon, but I mean it's all in contrib, so this is all public stuff. We were strongly incented to. The question was, do we have to do that? And the answer is, yeah, we're strongly incented to. I mean, nobody wants to go and say, well, we got lazy on the software side, so we need $10 million more. So,
putting more data on this or this in the system, making this much worse.
The question is if we're IO limited, making this much worse. So we're not disk IO limited. At this point now, we're going to be like network IO limited, because most of the data on any given node is going to be relatively unused from from in terms of like running jobs. But definitely, we're going to be host level network bottlenecked. So that's why that's a very valid point. So we're going to have to figure out some solutions for this. We don't have them today.
What you just said is, even though I'm putting more data on the node, that data never moves off the node. It stays on the node.
Right, the data generally is staying in one place for a long time. Maybe it gets, and I don't want to say it never gets access, but maybe one query per day or one query per week will run on it versus like hot data, right? And so this is like something I'm like wondering, like, is HDFS administration in 2012 going to be like administering a cluster of 4,000 NetApps? I don't mean to pick on NetApp. I like their stuff. It's just more like when the NetApp goes down, it's like it's a big deal, right? And when one data node goes down, now you're not supposed to care. It's just supposed to get failed over. It's just supposed to deal with itself. And now we lose one data node or one rack, and we're really in trouble. So the last thing, talking about things like NetApp and other vendors, we are big customers of lots of storage vendors, but we're always looking for ways to save money. And HDFS is pretty good now, pretty solid. And we have expertise in running it, we have expertise in deploying it, and we control our own destiny with we're building, Facebook's building our own hardware now, we have pretty decent terms with vendors, so we can get good prices on this hardware. And the software to run the storage is now with HDFS. It's pretty nice. So we're looking at this appliance model. We've actually deployed it. We have a few customers internally using it, and it's something we might be deploying more of now. So the question is, what changes from an operational perspective? Now you're talking about really the maintenance requirements being very low. It just has to work sort of out of the box, and it's no longer requires an HDFS developer to support each instance. We're just talking about something you can ship something and say, here, run this for the next 2 years. You don't have to, barring hardware, name node failure or whatever, you'll be fine. And if, by the way, if the name node does fail, just go to this wiki page and execute these instructions. You're back to business. So this is pretty exciting for us. Again, we're at the point where we can save a couple percent off of what our vendors can offer. That's big money. And so we have to look at all the alternatives. And Hadoop is a good one. So. Okay, so emerging operational best practices. I didn't say I had answers to all these questions, and part of this presentation is to just tell you what our challenges are this year and what we're going to work towards. So we're really going to need to be careful this year about what we do in a hardware and network perspective, like what machines do we buy, what kind of networks do we put together, what is the next generation Hadoop data center going to look like, and I can't tell you that yet. So I don't know. The second thing is dealing with this slowness. I talked about Hbase, we're talking about Monopoly, how slowness is really the enemy. What is being slow mean? Well, in the Hadoop case, we don't exactly know yet, but I guarantee you that inside of Facebook, we run a lot of high-volume transactional systems that do care about slow nodes, and they do have to get them out of their system. You know, systems that do things like ad pricing and ad bidding, and page serving, and all this, cache and all this other stuff. So there's people inside of Facebook that know how to solve these problems. Hopefully, we'll be able to take some of the wisdom. And now we have auto healing. Reboot or restart are kind of your options today inside of Hadoop. And things like the next generation job tracker are really going to help, I think, with being able to support better and more granular levels of upgrades, deployment, and restart. Things like node level version detection and installation. This is kind of like, this is back to that first slide that I showed you, things that Hadoop doesn't do. I wish it did, but it would be great if for example, today, a data node tries to talk to a name node and it's the wrong version, and the name node says, "You're the wrong version, go away." Well, that's not very helpful. Why can't you say, "Oh, and by the way, go here, and you can get the version to work," right? Or task tracker denied communication for the incorrect protocol version. Okay, what do I do now? Shut down. So, I mean, things like that, right? They're not that hard to do, but they're just not on the roadmap and in the mindset of people that have written the system up until now. Either because they didn't care or because they had bigger problems to worry about. I suspect the latter, because I work with them. And then finally, these rolling upgrades, zero downtime upgrades, Avatar, the new job tracker. These kinds of designs are really going to be cool, really going to let us go to the next level of availability and reliability. And on top of all this, do it all without making Hadoop harder to run instead of it already is, because it's already a pain. So, we're going to do all this, and we're not going to make things worse. We're just going to make things better. We hope. Okay, so, are we trying to do too much? As I was writing all these slides out, I was like, oh man, this seems like a lot of stuff. Well, we need a big data warehouse, Facebook. Yahoo does too. We need a large distributed file system for general purpose use. Probably some of you do as well. We need a database alternative to MySQL. We're the world's biggest MySQL shop, but MySQL isn't great for all applications. And we're always looking to spend less money if we can, right? So I guess I'm going to say failure is not an option. We're going to do all this, or Mark will fire us. So never a dull moment.